You might have visited some of these places in your past: a new school, college, or a mountain visit. For a first visit, it's obvious that you will have very general views about all the people over there, unless you know anyone from past. Once you start observing, well, everything changes. It's quite incredible that our brains start classifying like good, bad, humble, cheerful, based on the information gained by interaction, gestures, voices, or sometimes even by looks. That's how we make our friends, relation, or sometimes enemies.
What I love about Bayes' theorem that even without knowing what Bayes' theorem is, our mind is using it every single moment of life, except when we are sleeping.
To have the full understanding of this incredible theorem, let's jump to a story. Suppose you are planning to visit a new town, and there are two colleges in the town providing graduation in mathematics and science. We have 500 students in College A reading mathematics and 200 on science. For College B, we have 300 students for maths and 600 students for science. You got some plan in your mind to meet a student tomorrow. Now, what are the chances that the student is from College A? Instead of calling it College A and B, we are now calling it College 1 and College 2. Let's print out the same table where we have College 1 students, College 2 students divided into mathematics and science. Now to figure out the total students, we are going to sum this out and we will get 900 for College 2 and 700 for College 1. Let's add the column values also. So we have 800 students in maths and 800 students in science. And the total probability that the student is from College 1 will be 700, that are the student from College 1 divided by 700 plus 900, that are the total number of student. And in the same way, from the College 2, it will be 900 divided by 700 plus 900. This is quite straightforward because we are just taking the values into consideration. Now let's have the second case where we got a lead that the student is from the maths stream. What are the new chances that the student is from College 1? Let's pull out the same table and the sum. The student is from maths stream. We are giving it a name as event B, and we know that the event B has already happened. So the probability of being student from maths stream will be 800 plus 800 plus 800, that will be 1600. And now we have another event that the student is from College 1. We are giving it a name as event A. And the probability of event A will be 700 divided by 1600, that is coming out directly from the table. If we want to get the intersection between event A and event B, it means student is from College 1 as well as from maths stream. That will come out 500, that is over there, divided by the total number of students, that is 1600. And here we are going to apply the Bayes theorem. The Bayes theorem tells that the probability of happening of A when event B has already happened is equal to the probability of intersection between both the event divided by the probability of the event which has already happened. Just applying this equation, you are going to get the new probability. Sometime when you do a Google search, you may get the another form of the same formula. If you put the second equation in this formula, instead of probability B given A is true, then PA will cancel out the other PA, and then you will left with the same formula that we just now discussed. Let's jump into one step further. Now you have another information that the student is a girl. So now our table will be three-dimensional. On the top right corner, you can see we have 100 and 100, which sums out to 200 Science College 1 students. Same happened with the left hand top side, where we have 300 200, which sums out to 500 Maths College 1 students. And here is how our population looks like after pulling out all the dimension. So as many as information you will get, the dimension of this dataset will keep on increasing. Now you know, anytime you perceive any new information, you are adding up one column to the dataset you already have, and you are utilizing the Bayes theorem to create your perceptions.
When you see some of the finest invention of the century like a light bulb, I often recall a quote from Edison, not calling on the controversies. I didn't fail 1,000 times, I learned 1,000 ways to not create a light bulb.
But when it comes to the real life applications, people are using Bayes theorem to do a simple sort of forecasting to a rocket level simulation. One of the very new example, machine learning and deep learning techniques. So to say, thanks to the Bayes theorem. After this much discussion, we know that Bayes theorem has opened and still opening new opportunities for us every single day. My name is Jay and I will catch up with you in my next video. Till then, bye bye and take care.